Hi everyone, I'm going to be going over question number 4 from the chapter 14 bingo problems. This problem is pretty simple. It gives us this graph that I drew really poorly, and I apologize for that. I am not artistic at all. But it has this wave function, and it wants to know the frequency, amplitude, period, and angular frequency of this wave, given the information. So let's just start with part A. So we know that the frequency is equal to 1 over the period. And so I'll kind of do A and C together because they go hand in hand. Now, the period is the time that it takes for one complete cycle to go. So if it starts here, it's going to end. I tried to make this. In the book, it's about like that. Which is about 16 seconds, I guessed. So that means, the period is 16 seconds, because it's going to take 16 seconds to do one complete cycle. Now back to the frequency is 1 over the period, so that means 1/16. We'll just leave it at 1/16. And then the unit for that is hertz, which is Hz. So there's our frequency, there's our period. Now it wants the amplitude. So the amplitude is the distance from your baseline to one of the extremes. And so the base is 0 and the extreme is 10 or -10. We take the absolute value. So the amplitude is going to be 10 units, or gives us the units centimeters. So amplitude 10 centimeters. And now it wants the angular frequency. So the angular frequency, here's the equation. So it's 2 pi times the frequency. And so we know the frequency is 1 over 16. And then when we plug that into our calculator, and we end up getting 0.39, and the units are radians per second. So there's our angular frequency. So that's all this question wanted. So hopefully you learned something about finding the frequency, amplitude, period, and angular frequency when given a graph with a wave function. So I'll see you in the next video. Thanks for watching.